Well, let's start. Today I want to talk about Chrome, but most importantly about Chromium project behind it, and what tools you and me can use to contribute to it. So I bet everyone heard about Chrome, but maybe not everyone heard about Chromium project. It's an open source project behind Chrome, and of course you can go along and build a browser out of it, but it is never meant to be an end-user product. However, I should mention that you might see a Chromium-branded browser in some Linux distributions because they do package it and distribute it. But let's see what are the main differences between Chromium and Chrome. So the whole source code, almost the whole code of Chrome is in Chromium. The main difference is in branding, that we add the branding when we ship a Chrome browser. There are a few features which are not automatically compiled within Chromium when you build it, but the code itself is in a source code. So for example, crash reporting will not be a visible feature if you build Chromium code. And there are some other exceptions, like a plugin for Flush or some codecs, and mainly this is because of licensing issues. So everything that you have in Chrome, most of all, you can find the code in Chromium. Let's look more closely into the scale of the Chromium. It's a really huge code base. And according to OpenHub website, you can see that this project has around 10 million line of code, and around 2,000 contributors. It is mostly done with C++, but there are some parts which are done with other languages. And it is available for all platforms. And I should mention that there are other third parties that contribute to Chromium, and there are also a lot of individual enthusiasts who contribute to Chromium. And you can be one of them. So let's look into a bit of architecture for Chromium project. So the goal itself was to make a stable, fast, and secure browser. And it happened to be that multiprocess architecture was the answer for these three questions. And here, the main thing we can see is that each tab that you open has its own render process, and render process itself is in a sandbox. So let's look why is it so. Each tab has its own render process because maybe a website that the render process is trying to draw a website which is long to do or it's chunky. And in this case, a main process, which is the browser process, can monitor this stuff and still be interactive. And for example, if the render process takes too long to draw something, then browser process can decide to draw something from a little bit past. So whatever was returned to main browser from render process before, without user noticing that there is something junky going on with the render process. So this makes the browser to feel more stable and more fast. So the sandboxing. So sandboxing gives an opportunity to kind of isolate the render process so that if there is a bug in render engine, it is not possible to exploit it. Because when you put it in a sandbox, then the render engine cannot access the system or devices. In this basically helps us to keep the browser safer. There are other ways that Chrome addresses malwares. For example, there is a feature called safe browsing. You might have seen it. It's when you navigate to some URL that is known to have malicious content, then you will be warned with this red page saying that maybe you shouldn't proceed. So you can also see that plugins also have their own processes. Here, when I say plugin, I don't mean extensions. I mean things like Flush or Java or Acrobat. So they also have their own process because they also need some form of isolation. But it is not really possible to put them in a sandbox because of issues like Flash should be able to update itself, so it should be able to access the system. So you cannot put them really in a sandbox, but at least we can put them in a separate process so that if, for example, Flash is freezing, then main browser can notice it and suggest to a user that, you know what, Flash plugin is freezing, maybe you can just kill it. So the main browser process, it has multiple threads that you can work with. They are threads pre-assigned specific roles. For example, the main thread is called UI thread, and this is basically the main thread that when browser starts, it starts in this thread. Then we have IO thread, which is, I would say it is a bit misnamed, because it's actually for communication between the browser process and all these sub-processes that I talked about. And finally, we have file thread, which is in fact for IO operations, which actually blocks the operation. For example, Chrome has a local state saved on a disk which helps to persist user preferences. So this is an example of a file that Chrome might decide to open. And as for a Chrome developer, it's actually very easy to navigate between threads. You can just, from each thread, you can post a task to another thread and so on. So now let's imagine we are a Chrome developer and we want to contribute to Chrome. And we need to go through certain steps, and here is a sample of what we can do. First, we need to check out Chromium source code and build it. It sounds trivial, but I think this was the hardest thing I did the first month working at Google. So I will provide some steps how this happens, but I really encourage to go and check documentation of Chromium. It really does have up-to-date and very useful documentation that we use every day. So afterwards, we choose a bug we want to work on, we make our changes, and then we upload our patch to a review tool, which is a web tool, actually. Afterwards, we choose reviewers, send it for review, and it goes back and forth with reviewer. And I think the maximum I had back and forth was around 20 back and forth with different reviewers. It can get a bit long, but I still find it very useful, especially that I'm the person that chooses reviewers. I know from whom I want to get their feedback, and it usually improves my code tremendously. So afterwards, when you get all the approvals from reviewers, which we call LGTMs, looks good to me, then you are ready to commit the code. And for committing the code, you either can previously run all the tests and then be sure that everything is fine and committed, or you can just commit it and get if some tests fail, then you can get basically revert of your code. So let's move forward and go point by point. So for checking out Chromium code, first of all, you need to get these set of command line tools that help us, which we call depot tools. And when you have all these command line tools installed, then you're ready to fetch all the code. Okay, then half an hour later, you have all the source code. Afterwards, I would highly suggest to try to build it once. First of all, because it's going to be challenging, something's going to fail, but mainly because it's going to take really a while. And when you start coding, you don't want to wait an hour until you get a change, see the change of the result of your change. But if you do it before and then start your work, afterwards, incremental changes are going to go very fast. That's because we use a build system called Ninja, which is a tool developed at Google, but you can find it on GitHub. And it is built with this work compile cycle in mind, so that incremental builds are really fast. So afterwards, when we have all the source code, then we proceed to choosing a bug. So for bug, we have, this is also open to public. You can go see all the bugs that we have. And then, of course, there are a lot of filters and stuff. So I filtered the view with the bugs that I am assigned to. And then, let's say, I decided to work on this bug, and I'm ready to make my changes. So as I said, the code is really huge. So you choose a bug, but you have no idea where to start with. That's why we use code search extensively. You can see if you select a function or an object, you can see all the places that its function was declared, defined, called, referenced, all the links. So the way it works, the code search regularly scans all our source code and builds this structure of links. And then afterwards, you can search and see all the up-to-date code. So this helps. We find where we want to make our change. And then we move forward. We have all our source code on our disk. So the way I proceed, I leave the main source code in a master branch, and I make a branch for my own change separately. So because mainly if I decide to work on another problem, at the same time I can have a clean branch from my master, or if I decide to sync from a remote origin, then I will not need to clean up the mess. And this is useful, and also this is my advice. Afterwards, we Chrome developers, we are free to use any code editor, but I personally use Sublime. It's one of the popular ones. And then, let's say our change is ready. Then we use the same command line tools that we installed in our first step, called deploy tools, and send it to our review tool. This is how our review tool looks like. So it has like title, description, but you can also link it to the bug. Then you can see different patches that you made. So basically how the style works, you upload your first patch, send it for review, get a feedback from your reviewers, then you address them and upload a second patch. And then you can see, you can get a difference of your files with the original source code, or also you can compare it with the previous patch, and then it is very easy to navigate for the reviewer, also for you. Then you can run all the tests here on the bottom. These green things you can see, those are all the different configurations for which tests are run, different tribodes. And also each file has like a green rectangle next to it. It means for all the files, reviewers gave their LGTMs, so they are ready to be submitted. Okay, so speaking about reviewers, how to choose whom to send your reviews. You are free to send it to anyone, but whom you're going to choose. So basically, I have two stages of review for my changes. First, I send it to someone who is familiar with the context and the problem I'm trying to solve, so that I can verify the logic of my change. After I get this approval, I send it to so-called owners. So in our source code, we have files which are named like owners on the bottom, you can see, and it contains list of names. So if you change the file, which is in this directory, then you have to send it to one of the owners of this directory. If the directory doesn't have owner's file, you're going to go above so that you find an owner. So after all your files are covered with LGTMs, reviewers, owners of your files, then you would be ready to submit your change. After you submit your change, so there are thousands of tests running. But one of the very, very useful things is that it covers different configurations. For example, usually what happens to me, I would make a change having a specific platform in mind. I would make a change for Android, let's say. And I would build an Android version, I will try an Android version, and I would forget about all other platforms that we have. Then I will try all the tests, and it doesn't compile for Windows. So it's really hard to do these things manually, locally, every time you make a change. So this is tremendously helpful. I would even run all my tests before sending to reviewers to eliminate all these kind of small bugs. So when everything is green, basically, your code is submitted. So when your code gets submitted, then you get something like this post-it on your bug because you connected your change to a bug. Here you can see the description of your main change and review URL, which has all the discussion of your change and all the modified files. This is also, I find, very useful because if your bug would need multiple changes, then it's kind of grouped in your bug. Also, when I think back and I want to see what file I changed for this kind of problem, I usually don't remember the file name, but I can find the bug, and I can get to the change URL, and I can see what I changed there. So to sum up, I hope I managed to make you interested in Chromium project. There are a lot of interesting details that I didn't cover. You can find more information online. Chromium has a great website with a lot of explanations, technical explanations and everything. You can also access all the tools that I mentioned about the web tools like code search, code reviews, and bugs. They are all publicly facing tools. And of course, sources and command line tools also are very public, so you can access them. I speak really fast, so I finished very fast. But I'm ready to take questions here, and also you can send it to my Twitter.